So for those of you that are watching the recording, what we did is we had a couple of big bags of candy and we split them up by colors of the wrapper. So some of them, the wrappers were dark brown and some of them were other colors. And then by whether the candy had nuts in it or not. So we had things like peanut M&Ms that had nuts, but the wrappers for those are yellow. And things like Snickers that has a dark brown wrapper and has nuts. Here's what we got overall. And what we're going to do is look at some things to do with probabilities using some of these numbers. Let's say that we took all of the candy that we had and we just selected one piece at random from the entire assortment of candy that we had. If we just picked out one piece at random, we can think about the different possible outcomes. So we could either put this in terms of the name of the candy, like Twix or peanut M&Ms or whatever, or we could think about the color of the wrapper and whether it has nuts or not, the things that we looked at when we were counting them. The different possible outcomes we could have, if it has nuts and the wrapper is dark brown, that would be one possible outcome, or if it has nuts and the wrapper is another color. So really we're just looking at those 4 different spots in the table and writing down how we would describe those 4 different possibilities. We could have ones with no nuts and a dark brown wrapper, or we could have no nuts and another color. So if we think about it this way, there are really 4 possible outcomes. When we're doing probabilities, it matters a lot whether all of our outcomes are equally likely or not. So what do you think about this? Do you think each one of those 4 outcomes is equally likely? Why not? Because we got different numbers. They didn't all have equal numbers of candies. So the ones that were dark brown and had nuts, which would be the Snickers, had the most. And the ones with no nuts and another color, that was the Twix ones, were the least. The outcomes aren't equally likely because we don't have the same numbers of each kind. If we're thinking about calculating probabilities, we're going to select one piece of candy at random and we want to talk about probabilities for some of the different outcomes and for different events. What's another piece of information we would need? Yeah, how many total candies we had. We would need to know that so that we'd have something to divide by. Whenever you do a probability, on the top you have the number of how many of that kind are there, or the number of possible ways that that event can happen, but you have to divide it by the total that's in your sample space. In this case, how many candies there are. We need totals, like a total for the whole table. We might want to do some row and column totals also, but for sure we need a total for the table. The total that have nuts would be 72. The total that don't have nuts would be 52. The total with dark brown wrappers would be 83. And the total with other colored wrappers would be 41. And so our grand total for the entire table would be 124. One of the kind of confusing things with probabilities is all the different notation. For this, we use a capital P to mean probability. If we're talking about the probability of something, we'll have P and then parentheses, and then in the parentheses we either describe the event that we're talking about, or we have a letter that stands for the event. So we're going to call event A that the candy that we choose has a dark brown wrapper, and event B is that the candy we choose has nuts. Let's find P of A, or the probability of A. That's the probability that the one candy we select has a dark brown wrapper. To figure this out, we would want to know how many have dark brown wrappers. So we're going to do that on the top, and we're going to divide that just by the total number of candies that we had. This is one reason I did the row and the column totals. The total number that did have dark brown wrappers was 83. So we had the nuts and the no nuts, but altogether there were 83 that had dark brown wrappers. So this is going to be 83 on the top, and then we're dividing by the total number of candies, which is 124. A lot of times for probabilities, we'll leave them in fraction form. If you want to put that in decimal form, you can just divide it on your calculator. My stat lab usually has you round probabilities to 3 decimal places, and I always learn to round them to 4 decimal places. When you're doing your My Stat Lab homework, just pay attention to what it asks you for. If it asks you for 3 decimal places and you do it to 4, it'll tell you your answer is wrong. Just read the directions. So then the next one is this, where we have P of A, and that's A complement. In this textbook, when it has a bar over the event, that means it's the complement. The complement means it's everything that isn't in the original event. If our event A was that it does have a dark brown wrapper, the complement would be the opposite of that, that our candy does not have a dark brown wrapper. That's how we could describe a complement. A lot of times when you're doing the complement of something, all you really have to do is put the word not in there. The original event was that it does have a dark brown wrapper. The complement is that it does not have a dark brown wrapper. So if we had event B that the candy has nuts, the complement would be that it does not have nuts. To find the probability of our complement, we could either find it directly by looking at our table and seeing how many had the other colored wrappers, which was 41, or for complements, if you already have the probability of the original event, you can take that and subtract it from 1. So we could just do 1 minus the answer that we had up here. And sometimes it's a lot easier to find the probability for the complement than it is for the one directly. This one, it really wouldn't really matter. And let's look at our event B, and that was that the candy has nuts. If we're going to find the probability of that, we just want to see how many total had nuts and then divide that by the total in our table. For the nuts, we had a total of 72. The total in our table was 124. If we wanted to do P of B complement, that would be the probability that it doesn't have nuts. That could just be 1 minus this. Or we could get it directly from our table. The ones that didn't have nuts, there were 52. Both ways it would give you the same answer. If you have a table like this, or if you can fill out a table like this, then it's actually pretty easy to find the probability of two things together. If we're saying the probability of A and B, that means we're taking these two events and saying they both have to happen at the same time. Probability that it has a dark brown wrapper and it has nuts. We can just look at our table because we already actually have it divided up, so we can tell how many there were that have both of these things. Dark brown and does have nuts would be this cell in our table right here. We've actually already got that total, so that would just be 51, and we're still dividing it by the total in the table. So for this, if you have the table, all you're looking for, if you have an and, is just do the intersection of the row and the column in the table that have those two conditions. It's like this one, we're just doing the intersection of this column and this row, and that turns out to be that one cell right there. That's how many candies there are that have those two conditions, and then we're just dividing it by the total. This one, the difference is that it has an or instead of an and. If we wanted to write this out with the probability notation, it would be A or B. This is a really important thing to notice, is whether there's an and or an or, because it makes a huge difference as to how you figure it out. If you have an or, then you have to use what we call the addition rule, and there are two ways to think about this. Here's in the notes where it talks about the actual addition rule. We could use this one because we've actually figured out all three of those things already. If we're trying to find the probability of A or B, we could take the probability of A that we figured out in number 1, plus the probability of B that we figured out in number 3, and subtract the probability of A and B that we figured out in number 4. So that would be 83 over 124 plus 72 over 124 minus 51 over 124. And what's kind of confusing about this is why we have to subtract that 1. If we go and look at the table, we need to count up all the ones that either have a dark brown wrapper or that have nuts or that have both. What we're looking at is the dark brown wrapper. There were a total of 83 of those. The ones that have nuts, there were a total of 72 of those. If we just take those two totals and add them together, then these ones right here we've actually counted both times. So we counted these ones once when we did this total. We counted them again when we did this total over here. Because we counted that twice, that's why we have to subtract it back out. That way we're only counting that once. So another way that we could do this, instead of using this actual rule right here, is that we could just take and look at the different cells in the table that would meet either one of these conditions. If it's dark brown wrapper, it would be either this or this one. So it would be either this cell or this one, and then if it has nuts, we've already got that one marked, or it also could be this one. The 3 cells in the table we'd be looking at would be these 3. Those are the 3 that meet one of those 2 conditions. So we could just take those 3 numbers and add them up, 51 plus 24 plus the 32, and get that total, and then divide that whole total by 124. That would give us the same answer as what we would get by doing it this way. Let's look at these 2, also with the first 2 that we had. So we've got these 4 different events. Let's look at event A and event C. One thing we talk about a lot with probability is whether events are disjoint or not. In other words, whether they can both happen at the same time or whether they can't. You think these 2 can happen at the same time? So A was that it had a dark brown wrapper, C is that it has another colored wrapper. No, they can't happen at the same time. Either has to be dark brown or it's another color. The answer to this is yes, they're disjoint. In other words, they don't overlap at all. So one way you can think about this is if you draw a Venn diagram with the circles for the different colored wrappers. We'd have the dark brown ones over here, and we'd have the other colored ones over here. There's no overlap between those 2 circles. So there's nothing that's in both of them. And even if you look at it with the table that we made, those are 2 different columns. If they're 2 different columns, or if they were in 2 different rows, then they wouldn't have anything in common. How about event B and event C? So B was that it has nuts, and C is that it has another colored wrapper. Are those 2 disjoint, or can they have some overlap? Yeah, they have overlap. If you look at them in the table, one is a row and the other one's a column. That usually means that they're going to have an overlap. B was that it has nuts, so that would be this row. And C is that it has another colored wrapper, so that would be this column. So yeah, they do have an overlap right there. Those 2 are not disjoint. If we drew it as a Venn diagram, this could be our event B, that it has nuts, and this would be that it has another colored wrapper. And we have these ones in the middle that have both things. They have nuts and another colored wrapper. One of the reasons for figuring out whether things are disjoint or not, it makes a difference if we're doing a probability where we have to use the addition rule. If we were trying to do the probability of A and C, that would mean the probability that both of them happen at the same time. But we decided that they were disjoint, so they don't have any overlap. That means the probability of them both happening at the same time is 0. If we're trying to find the probability of A or C, since they don't overlap, that means if we do our addition rule, this part is 0 since there's no overlap, so we don't have to worry about that. And actually for this one, the probability of A was 83 over 124. The probability of C would be 41 over 124. That's 0. And actually if we add these 2 together, we end up with 1. All the candies either have a dark brown wrapper or they have another colored wrapper. So the probability of selecting one or the other of those is just 1. If we're doing the probability of B and C, B was that it has nuts, C is that it has an other colored wrapper. Again, we can just look at the table and see where these 2 things overlap. So where the row and the column intersect each other. We have nuts, it was this first row. For the other colored wrapper, it was the second column. The number that have those 2 conditions together would be 21. And then we're going to divide that by the 124. If we wanted to do probability of B or C, that's where we could either do that addition rule, or we could just count up the cells in the table that would count for these. So if we did it that way, we'd have the ones that do have nuts would be the 51 and the 21. And then we also want the ones with the other colored wrappers. We already counted the 21. The other one in that column is the 20. We could just take those 3 cells and add them up and then divide by 124. That's going to be 92 over 124.